Alright, in this video I'm going to talk about how to use a solubility chart to determine the solubility of an ion. Here, let's make this all a little bit bigger. There. So, if we have some sort of ionic compound, like let's say, I don't know, lithium chloride, how do we determine if that's going to be aqueous, as in soluble in solution, or whether or not it's going to stay as an ionic crystal? That's what this chart helps us do. The way we use this chart is we look for either element. So we're looking for lithium and chlorine. We start at the top of the chart and we work our way down. The first time we see the element, that tells us the solubility. So we use whichever rule or whichever guideline comes first. So in our first example here, lithium chloride, if I start looking at the chart, I'm going to see chlorine is down here and lithium is up here. Since lithium is in the top guideline, or guideline number 1, we're only going to pay attention to lithium. Lithium is soluble, so I know that this entire compound is soluble. Alternatively, if I had something like lead chloride, finding lead, it's right here. Finding chlorine, it's down here. Now we have a conflict here. Lead is insoluble and chlorine is soluble. So which one is it? Well, since lead is higher than chlorine, we would say that this is insoluble. We use whichever guideline we get to first. So the 1 are the most important guidelines, 2 are the second, 3 are the third, and so on. Let's go again. Let's look at copper sulfate. Make a copper 2 sulfate. Looking at the first row, I don't see any. Second, third, fourth, so I got to go all the way down to the 5th. I find copper and I find sulfate. So this is soluble. We see also that there are some exceptions up here. So if the chemical you're looking for is directly specified up here, then obviously you look over here to make that decision. One more example. How about calcium sulfate? Calcium's here, sulfate's here. Here we have a disagreement. We have one that's insoluble and one that's soluble. But calcium is in guideline 4, which is better than 5. So this is insoluble. One more time, you identify the cation ion, look for it in the chart. Whoever comes to the top of the chart, you use their guideline in terms of whether they're soluble or insoluble. And then the person who's lower in the chart, it doesn't matter. And keep an eye on the exceptions. There aren't too many, but if there is a exception, you want to pay attention to it over here. So that's how you use the solubility chart to determine solubility.